Hello everyone and our lecturer. We are the group 6. Today we wanted to present about our course EDI 3013 Engineering Mathematics 1. Our lecturer is Dr. Nuafnida Afriza. Our presentation title is A Vectors. Here is our team member. I am the first. My name is Tan Ziwei and matrix number F72201. Our second member is Leung Woon Ho. Matrix number is F72003. And our third member is Tai Jia Wen. And matrix number is S72078. And our last member is Chen Gok Kwan. And matrix number is S70483. So for the first, I will present about the introduction of a vector. Vector calculus or called vector analysis is a field of study that focuses on the differentiation and integration of vector fields, especially in three-dimensional Euclidean space. Vector fields represent the distribution of a vector to each point in the subset of spans, and are represented as vector value functions that combine real number to each point on the domain. Vector analysis deals with quantities with both magnitude and direction, and deals with two integrals, such as line integrals and surface integrals. For the below picture, it is show the arrow of the vector. We can see what is the magnitude and his direction and his type and his heat.
In the 19th century, vector emerged as geometric representation of complex numbers used to push the fundamental theory of algebra. Hamilton extended two-dimensional numbers to three dimensions and invented quaternions in 1835, Peter Quaternions applied quaternions to electricity and magnetic sparking scientific relations. Hermann Casimir developed a new geometric calculus in 1832, simplifying Cauchy's work and expanding vector conception, preparing mathematics and linear algebra. William Hayden a mathematical introductor in his 1878 work, "Announcement of Dynamic Will Influence Mathematical Science". Hence and other different dichotomies, while others developed their own better method. Oliver Hepburn-Sykes, influenced by Maxwell, published electromagnetic theory, attacking quaternions and development method analysis. Hepburn-Sykes introduced Maxwell theorem to German, leading to introduction of vector method in Italy, Russia, and the Netherlands. Vectors are now is modern language of physics and applied mathematics.
In physics, vectors are crucial in physics, representing physical quantities like force, velocity, acceleration, and momentum. They aid in analyzing and predicting object motion in mechanics and describe electric and magnetic fields and their interaction with charged particles in electromagnetism. In engineering and structural analysis, vectors are crucial in engineering for structural analysis and design, representing forces like tension, compression, and shear. They help determine structural stability and strength and design efficient solutions. In civil engineering, vectors are used to analyze bridges, buildings, and infrastructure projects. Computer graphics and animations. Vectors are essential in computer graphics and animation, where they are used to represent geometric geometric transformations such as translation, rotation, and scaling. The graphic programmers utilize vectors to define the position and orientation of the object in virtual environment, enabling the creation of the realistic simulation and visual effects. The vectors also facilitate the rendering of the 2D and 3D graphic, allowing the developers to create immersive gaming experience and visually appealing user interfaces. Fluid dynamics. In fluid mechanism and aerodynamics, vectors are used to describe fluid flow, pressure distribution, and force acting on objects immersed in fluids. They help engineers to analyze and optimize design of pumps, turbines, aircraft wings, and other fluid handling devices.
Hi, I'm Yong Wan Ho. Now I will explain about the example of the vector that used in different field. So the first is used in the military usage. So a cannon is an artillery piece that fires a projectile using a gunpowder or explosive propellant. So its characteristics include caliber, range, mobility, range of fire, and also the angle of fire. So the different types balance these characteristics will based on their role on the battlefield. So it shows that the vectors determine the direction of the projectile and its impact on the ground in this mileage usage. And the second is the projectile. So the example of projectile is the baseball vector is used by the players in the sports like baseball, basketballs, and also the baseball to shoot or throw the ball at an angle. So in games like javelin throw, it's crucial to judge the angle the projectile vector makes with the ground to ensure the javelin can travel as far as possible. And a third example of vector is also in the vector in gaming. So vectors are utilized in the storage of the locations, directions, and also the velocities in the video games. So the position vector tells us how far away the object is. So the velocity vector tells us how long time it will take or how much force we need to apply. So and the direction vectors tell us how we should apply that force. Okay, and the last example is the roller coaster. So roller coaster describes primarily driven by the Earth's gravitational pull. So when a train that hits a high point and descends, it gains enough speed to be affected by the gravitational attraction. So it will reaching the next hill. This process repeats until all energy is dissipated due to the friction. So the safety system design considers the vectors of forces, accelerations, and velocities. And it is to ensuring the train can continue operating as long as no point is higher than the initial peak. So that's all our presentation from our group. So thank you so much.